Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, Official Guide to the Revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 246. Please turn to it. Page number 246, and today is our lesson number 361. These problems that you see there on page number 246 are the exact same problems that appeared in the first edition of the revised GRE. We already solved every single problem from this book. If you are interested in watching the original solution to the problem, you will find the original solution on day number 156. Let's get going. Problem number 21 is what we are starting here. The very first one, the part A. Problem 21. And in these problem, because there are several parts here, they are asking for three things. They are asking for the domain of the function. We have to describe the function. And we have to give X and Y intercepts. So those are the three things we're looking for each of these functions that are given to us. The very first one is f of x equals a -4. And of course f of x equals -4, and f of x of course is the value of the y, so y equals -4, and that's our function. That's it. How do we plot it? What is going to be the shape of this function? Well, it's very straightforward. Here is our xy axis. Now, if you look at it and you ask yourself, how much is the value of this function when x is equal to 0? Well, when x is equal to 0, y is -4. Y is -4. Is it -4? Oh, it's -4, exactly. So right here. 1, 2, 3, 4. Right here. When x is 0, y is -4. How much is well, the value of y when x is 1? It's still -4. Why? Because x doesn't even appear in this problem. Y is constant. It's -4. No matter what the value of the x is, x doesn't appear in the problem at all. So no matter what the value of the x is, y is always -4. Y is always -4. When x is -1, y is -4. When x is -2, y is -4. When x is +5, y is -4. This is it. This is it. Oh, I shouldn't have put those. That's it. That's our line. That's the function. The function of this graph. Let me do this now freehand. This is silly here. Let me do this freehand now because this looks kind of ridiculous. So here's the graph of this function. Here's the x-axis. Here's the y-axis, and here you go. Y equals to -4. So they're looking for the description of the function, but the description is very simple. What's the description of this function? This is a horizontal line. This is a horizontal line parallel to y-axis, parallel to x-axis. At y equals to -4. At y equals to -4. What's the domain of this function? What's the domain of the function? And what does it mean? What does it mean? What is the domain of the function? What does this mean in English language? When somebody asks you what's the domain of this function, how do you translate that into English language? What is it asking? It's asking us what values is x allowed to take? Which is a moot point here. Why is it a moot point? It's irrelevant, it plays no part here, it has no practical importance, it has no practical significance here. Why? Because x doesn't even appear in the x doesn't even appear in the function. Y is just constant. It's -4. So what value is x allowed to take? It doesn't matter because x doesn't even appear here. X can take whatever value it wants to be. For example, there are some functions where, let me give you a simple example here. If we say that y is equal to root of x, what value is x allowed to take? Can x be anything? Can x be positive, negative, 0, anything? In this function, y is equal to x, root of x. The answer here is that in a function such as this one, here, x is not allowed to be negative. Here, x is not allowed to be negative. Why? Because we can't take a square root of a negative number. If somebody asks you, what's the square root of -9? If somebody asks us, what's the square root of -9? What they're asking here is that, what is that number which, when multiplied by itself, is going to give us -9? And the answer to that question is, what is that number which, when multiplied by itself, is going to give us -9? Answer to that question is, there is no such number. There isn't any number. It doesn't exist. Because a number, any number, is going to be either positive or negative. So if it's a positive number, you multiply it by itself, you're going to get a positive answer. If it's a negative number, if you multiply it by itself, or negative times negative is going to become positive. You can't take a square root of a negative number. So here, if somebody asks you what's the domain of this function, domain of this function is 0 or positive number. Here, the domain is going to be, x has to be greater than or equal to 0. Is there any restrictions here? The answer is no. What values is x allowed to take? The answer is x can be any value it wants to be. X can take any value. And how do we say it in mathematical language? We say the domain is all real numbers. Domain is a set of all real numbers. So we took care of domain, we described the function. The description is, what's the description of this function? This function is just a horizontal line parallel to x-axis rather, and y is equal to -4. Let's talk about the y-intercept and x-intercept very quickly. Y-intercept and x-intercept. So here is our function, 1, 2, 3, 4. This is where our line is. What is the x-intercept of this function? Where does this line cut x-axis? The answer is, it has no x-intercept. It has no x-intercept. Why doesn't it have any x-intercept? Because it's parallel to x-axis. How is it going to cut the x-axis? That's what it means to be parallel to something. If it's parallel to x-axis, it's just going to be parallel forever and ever until infinity. It's never going to cut the x-axis. It has no x-intercept. What's the y-intercept? Oh, y-intercept is very straightforward. It's right here. The y-intercept. Where does it cut the y-axis? Y-intercept is when x is equal to -4. That's all. Or rather, when y is equal to -4. When y is equal to -4, right here. This point, the y-intercept is 0 and -4. That's it. We're done with this problem. Let's go on to the next problem. Part B. Part B. So remember, there are some functions where there are limitations. X cannot just take any value it wants to be. In some functions, depending on the nature of the function, there are some limitations on the values of x, the values that x can assume. Another example is this one. If we say that y is equal to 1 over x, here, x cannot be 0. Why? Because any number divided by 0 is infinity. It's undefined. Here, x cannot be 0. So what's the domain of this function? The domain of this function is set of all real numbers except when x is not equal to 0. So here the domain is all real numbers except x equal to 0. Domain is all real number except x equal to 0. If somebody were to ask you what's the domain of this function, y is equal to 1 over x. What's the domain of this function? The answer is, its domain is all real numbers. X can be whatever the hell it wants to be as long as it is not 0, which is what this says here. Domain is set of all real numbers except x equal to 0. Here's another one. Can you tell me what's the domain of this function? Y is equal to 1 over x plus 2. Remember, the bottom cannot be 0. Bottom cannot be 0. Bottom cannot be 0. Why? For the same exact reason that we just described here. Because any number divided by 0 is going to be infinity. It doesn't even have to be 1. It could be anything. At the top, it doesn't matter what it is on the top. It makes no difference. Any number divided by 0 is infinity. So we can't have 0 in the bottom. When is the bottom going to be 0 here? The bottom is going to be 0 here when x is equal to negative 2. So here, if somebody asks you what's the domain of this function, domain of this function is all real numbers except when x is equal to negative 2. X cannot be negative 2. Let's do the next part, part B. In part B, we have a function that looks like this. We are told that f of x equals 100 minus 900x. Again, as we can tell by looking at it, it's a linear equation. It's a linear equation. Linear equation. What does it tell us? It tells us that it is an equation of a line, a straight line. Let's write this thing in a standard form. The equation of an equation of a line, written in a standard form, in a slope-intercept form, looks like this. Let's write it in what is known as the slope intercept form. And the slope intercept form looks like this. Y equals to mx plus b. Y is equal to mx plus b. And when it is written in this form, the m represents the slope. M is the slope. And this b here is the value of y when x is equal to 0. When x is equal to 0, y equals b. But when is x equal to 0? If you have a line here, here's your x-axis, here's the y-axis. When is x equal to 0? X is equal to 0 along the y-axis. So this part here, when x is equal to 0, whatever the value of the y is, it represents the y. This is your y-intercept. Y is equal to b, this is your y-intercept. B is the y-intercept. Because b is the value of y when x is equal to 0. Plug in 0 here, it doesn't matter what m is, it doesn't matter what the slope of the line is. Any number times 0 is just 0. So if x is 0, m times 0 is going to be 0, and y is going to end up being equal to b, which means when x is equal to 0, we are talking about along the y-axis. When x is equal to 0, whatever the value of the y is, that's your y-intercept. It may be positive or it may be negative. You may have a line that goes like this, in which case the y-intercept is here, and down here in the negative. So let's write this equation in this form. Let's write this equation in the slope-intercept form, shall we? Let's do it here. So we are told that y is equal to 100 minus 900x. But it has to be written in this form. It has to be written as mx plus b. mx plus b. mx plus b. M is the slope, x is the variable. So this part here, x part, this is your m. This has to be written first. mx, and then b is the constant, which is 100 here. So we have to write this first and then that. So it has to be written as y is equal to negative 900 plus 100. Oh, sorry, not negative 900, negative 900x. Negative 900x plus 100. And now we can see that the slope of this line is negative 900. Slope of this line is negative 900, and the y-intercept is 100. Y-intercept is 100. Let's plot it, shall we? Let's plot it. We need the room, obviously, so we need to erase this thing. Again, f of x equal to 100 minus 900x, we can tell immediately this is a linear equation because the power of 1, x is just raised to the first power, it's a linear equation, and therefore it's an equation for line. and we have to write it in what is known as slope-intercept form. Slope-intercept form is this, mx plus b. We just found out that when we write it in this form, it boils down to minus 900x plus 100. Therefore, our slope is 900. Our intercept is 100. So let's go in sequence so that we don't leave anything out. The first thing they're asking is the domain. What is the domain of this function? When somebody asks you what is the domain of this function, what they're asking you here is, are there any restrictions on x? Are there any values that x is not supposed to take? When somebody asks you what's the domain of the function, what are they asking you in English language? How do we say the same thing in English language? This is the language of mathematics. What's the domain of this function is the language of mathematics. What does it mean in English language? In English language, it simply means, are there any values that x cannot take? That's what they're asking here. We did a couple of examples a little while ago. For example, if we have a function that looks like this here, x is equal to 5 over x plus 7, are there any values that x cannot take in this function? The answer is yes. Here, x cannot be 7, or rather negative 7. X cannot be negative 7, because what would happen if x were negative 7? This is purely hypothetical. X cannot be 7. If x were negative 7, then what would happen? We would have a negative 7 plus a 7. We'll end up 0 at the bottom. We'll end up with 5 over negative 7 plus 7, 5 over 0. We can't have that. We cannot divide anything by 0. Anything divided by 0, any number divided by 0 is undefined. We cannot have 0 at the bottom. So if somebody asks you what's the domain of this function 5 over x plus 7, what they're asking you here is, are there any values that x cannot take? To which the answer is yes. There is one value that x cannot take here, x is not allowed to take here, and that value is negative 7. Domain of this function is all real numbers. When you say all real numbers, in English language what we're saying is that x can be whatever the hell it wants to be, except negative 7. It cannot be negative 7. Are there any restrictions here? Are there any restrictions here? The answer to that is no. Here it doesn't matter. X can be positive, x can be negative, x can be fraction, it can be anything. Domain of this function, are there any values that x cannot take? The answer is no. The answer is no. That means the domain, there are no restrictions. Domain is a set of all real numbers. Now don't worry about the fact that we keep making about the fuss that we always qualify it, we always put the word real numbers. Why do we have to say real numbers? Because in the language of mathematics, mathematicians live in two worlds. They live in the real numbers and they also live in the world of imaginary numbers. Don't worry about that, as I said. They do not appear in the GRE. You will never have to deal with it in your real life. You only worry about it if you're getting your master's or doctorate in mathematics. Ordinary souls do not deal with imaginary numbers. But we still have to say that it's a set of all real numbers. Do you understand? Set of all real numbers, that's it. So that's the domain. Let's keep on going. I just used a couple of words here a little while ago. We'll talk about them in a second. A little while ago I said, why do we have to say a set of all real numbers? Why do we have to qualify it by saying that it has to be real numbers and not just set of numbers? Why do we have to qualify by saying real numbers? We'll learn the word qualify in a second, in that context, in a second. And then a little while ago we used the word moot point. When we said y is equal to negative 4, here somebody asks you, what's the domain of this function? They're asking you, what are the restrictions on the values of x? Well, that's a moot point because x doesn't even appear here. It's a moot point. It doesn't matter. It plays no practical significance here. It has no practical implication here. It has no practical bearing on here because x doesn't even appear here. It's a moot point. To ask here what are the restrictions on x in this function is a moot point because it's not even there. So that's the domain. The second part that we're talking about is the graph. Let's plot this graph very quickly. So here's our x-axis, here's our y-axis. Y is equal to negative 900, x plus 100. When x is equal to 0, we'll get y is equal to negative 900 times 0 plus 100. You see, it doesn't matter what but the slope is any number times 0 is just 0. So y is equal to positive 100. So that's your y-intercept here, right here, 100. Now let's find the x-intercept. X-intercept is where, let's find the x-intercept. Let's find the x-intercept. The x-intercept is where the line cuts the x-axis, is where the line cuts the x-axis. And what's the y-coordinate at that point? When line cuts the x-axis, that's where y is equal to 0. That's where y is equal to 0. So we're just going to set this equation is equal to 0 and we're going to solve for x. That's all it is. Let's do it here. Oh, I erased those two words. Let's get them out of the way so I don't have to keep worrying about it. I'm going to give you the days when we learn these two words in the event that you are curious and in the event that that you are interested in improving your vocabulary. Day 27. To qualify a statement here, learn the meaning of the word. This word qualify has a different meaning, other meaning than the ordinary meaning that we typically use in our conversation. Moot point. When did we learn? 27. Day 27. It simply means just type in vocabulary words. Day 27, and you will find it. I'm looking for the list of M's for the moot point. Oh, it's day 7. Day 7. Just again type in vocabulary words day 7, and you will see a video. You will watch a video where we will learn the word moot point along with some other useful and good words. So again, let's set y equal to 0 so that we can find the x-intercept. So y is equal to 0. Y is equal to 0 here. Y is equal to 0 right here, which means 100 minus 900x equals to 0. Bring the 900 to the other side and we find that 900x is going to equal 100. If you bring 900x to that side, we get 900. We get 900x equals 100. Divide both sides by 900. Let's divide both sides by 100 first, and then divide both sides by 9, and x equals 1 over 9. So here is your x equals 1 over 9. This is your x-intercept, and there is your line. There we go. And here, the coordinates are 0 and 100. So this is your y-intercept, this is your x-intercept. Notice one thing very quickly, that the scales are different. The scales that I always remind you when you're plotting a graph, the scales on the x-axis and the y-axis do not need to be the same. Here I'm saying all the way from here to here is just 1/9, whereas over here we are saying from all the way from here to here, this distance we're claiming is 100, and that distance we're claiming is 1/9. It's okay, it's perfectly fine. You have to be consistent along a given axis. You cannot, for example, we cannot draw a line here and say, we cannot draw something like this and say that this is 1 and this is 2 and this is 3. No, this will be silly. We cannot say this is 1 and this is 2 and this is 3. This will be silly. Along the axis, they have to be consistent. You have to be reasonable. But it's okay, it's perfectly okay to use two different scales on the two different axes. So if you have an axis here, you have to be reasonable. 1, 2, 3. They have to look, you have to eyeball it. They have to be a little bit reasonable. But here it doesn't matter because we are only showing 1 point. So we don't have to worry about being reasonable. But the scales are very different. Here, 1 here along x-axis, 1 would be 9 times this distance because this is only 1/9. So if you take 9 times that amount of distance, that's what we're calling 1, which can be way over there. Whereas 100 is only from here to here, which is perfectly fine, as I said. What else are they asking for? They're asking us to describe the function. We just did it. We just described it. It's a straight line. They're asking us to give us the domain. We just did it. Domain of this function, we said it's a set of all real numbers. And they simply ask, and lastly they're asking for x-intercept and y-intercept. So here's your x-intercept and there's your y-intercept. That's all. I'll see you tomorrow, okay? Bye now.